Hello everyone. And welcome back once again to another interesting video. In this video we'll discuss the most commonly asked Python interview questions and answers which will help you excel and bag amazing job offers. Each question is accompanied by explanations, tips, and examples to help you prepare thoroughly for your interview. So if you are ready, let's start today's video. Question 1. What are dict and list comprehensions in Python? Answer. List comprehensions and dictionary comprehensions are concise and powerful ways to create lists and dictionaries in Python. They offer a more compact and readable alternative to traditional for loops. Let's discuss one by one. 1. List comprehensions. This is the syntax of list comprehensions. Where new_list stores the resulting list. Expression is applied to each element in the iterable, like a list, tuple, or string. Iterable is the data source you iterate through. Condition is an optional filter to include only elements that meet the condition. Here is the example to illustrate the list comprehension. In this example, we have a list given numbers containing numbers from 1 to 5. The comprehension, number for number in given numbers, creates a new list named squared_numbers. For each number in the numbers list, it calculates number that is squares of the number and adds it to the squared_numbers list. So, list squared_numbers will become 1, 4, 9, 16, 25. 2. Dictionary comprehensions. This is the syntax of dictionary comprehensions. Where new_dict stores the resulting dictionary. Key_expression defines the key for each item in the dictionary. Value_expression defines the value for each item in the dictionary. Iterable is the data source you iterate through. Condition is an optional filter to include only elements that meet the condition. Here is the example to illustrate the dictionary comprehension. In this example, we have two lists, names containing names and ages containing corresponding ages. The comprehension creates a new dictionary called name_age_dict. Zip, names, ages, combines elements from both lists into tuples, name, age. For each tuple in the zipped list, it creates a key-value pair in the dictionary. The key is set to the name and the value is set to the age. Benefits of using comprehensions. 1. Readability. Comprehensions can often make code more readable than traditional for loops, especially for simple operations. 2. Conciseness. They express complex logic in a single line of code. 3. Efficiency. In some cases, comprehensions can be more efficient than for loops. While comprehensions are great for concise data manipulation, complex logic might be better suited for traditional for loops for better readability. They are most effective when working with iterables. Question 2. What is Lambda in Python? Why is it used? Answer. In Python, a Lambda function is a small anonymous function defined using the Lambda keyword. It can take any number of arguments but can only have one expression. Lambda functions are typically used when you need a simple function for a short period and you don't want to go through the process of defining a formal function using the def keyword. Here's a basic syntax of a Lambda function. Lambda functions are commonly used in scenarios where you need a function as an argument to higher-order functions like map, filter, and reduce, or when you want to create simple one-liner functions without formally defining them. They are particularly useful in functional programming paradigms. Here's an example of using a Lambda function with map to square a list of numbers. While Lambda functions offer advantages for concise code, they can sometimes become less readable for complex logic. It's generally recommended to use Lambda functions for simple expressions and prioritize readability for more intricate operations. Question 3. What is pickling and unpickling in Python? Answer. Pickling and unpickling are the processes of converting Python objects into a byte stream or serialization and back again, deserialization, respectively. They are achieved using the built-in pickle module in Python. Let's understand one by one. Pickling. Pickling takes a Python object and converts it into a format that can be stored or transmitted. This byte stream representation is not human readable but can be efficiently saved to a file or sent over a network. The pickle.dumps function is used for pickling. It takes the object as an argument and returns the corresponding byte stream. Unpickling. Unpickling takes the pickled byte stream, obtained from pickling, and reconstructs the original Python object from it. This allows you to retrieve the object in its original form for further use. The pickle.loads function is used for unpickling. It takes the byte stream as an argument and returns the recreated Python object. Use cases of pickling and unpickling. 1. Saving and loading objects. Pickle allows you to save the state of an object, including its data and attributes, to a file. You can later unpickle the file to recreate the object in its original state. This is useful for caching data, persisting application state, or sharing objects between different parts of your program. 2. Transferring objects over networks. Pickled objects can be transmitted over networks, like sockets or databases, because they are represented in a binary format. On the receiving end, the object can be unpickled to regain its original form. Pickling can be a security risk if you unpickle data from an untrusted source. Malicious code could be embedded within the pickled data and executed when unpickled. It's generally not recommended to unpickle data from external sources unless you have strong security measures in place. Pickling can be version dependent. If the class structure of the object changes between pickling and unpickling, the unpickling process might fail. Consider using alternative serialization methods like JSON if compatibility across different Python versions is crucial. Overall, pickling and unpickling provide a convenient way to serialize and deserialize Python objects for storage or transmission. However, it's essential to be aware of the security implications and potential compatibility issues before using them in your applications. Question 4. What are generators in Python? Answer. In Python, a generator is a special type of iterator that generates values on the fly using the yield keyword. Generators are functions that produce a sequence of results instead of a single value, allowing you to iterate over the generated values one at a time. They are particularly useful when dealing with large datasets or when you want to generate values lazily, as they consume less memory compared to lists or other data structures that store all values at once. Here's a simple example of a generator function. In this example, count_up_2 is a generator function that yields numbers from 1 to n. When the function is called, it doesn't execute immediately. Instead, it returns a generator object. The actual execution of the function happens when you iterate over the generator object, as demonstrated in the for loop. Generators offer several advantages. 1. Memory efficiency. Generators produce values one at a time, so they don't require storing the entire sequence in memory, making them more memory efficient, especially for large datasets. 2. Lazy evaluation. Values are generated on demand, which means computation is done only when needed. This is useful for scenarios where you might not need all values up front. 3. Simple and readable code. Generators often lead to cleaner and more readable code, especially for tasks that involve iteration or processing sequences of data. Overall, generators are a powerful tool in Python for dealing with sequences of data, especially when memory usage or performance is a concern. Question 5. What is the difference between .py and .pyc files? Answer. The main difference between .py and .pyc files in Python lies in their purpose and how they are used by the Python interpreter. 1. .py files. These are Python source code files written by developers. They contain human-readable Python code that can be edited and executed directly by the Python interpreter. When you write Python code and save it with a .py extension, it means you're creating a Python script or module. Python source files are compiled into bytecode by the Python interpreter when they are executed. This bytecode is stored in memory during runtime but is not saved to disk unless explicitly requested. .py files are primarily used during development and deployment phases. 2. .pyc files. These are compiled bytecode files generated by the Python interpreter. When a .py file is executed for the first time, the Python interpreter compiles it into bytecode and stores the bytecode in a separate file with a .pyc extension, or .po4 optimized bytecode in some cases. The purpose of .pyc files is to speed up the loading time of Python modules. By storing the bytecode, Python can skip the compilation step if the source.py file hasn't changed since the last time it was compiled. If the corresponding .py file is modified, the Python interpreter automatically recompiles it into bytecode, updating the .pyc file. .pyc files are platform independent, meaning they can be distributed and executed on different platforms without requiring recompilation. .pyc files are typically found alongside their corresponding .py files and are used by the Python interpreter to execute Python code efficiently. In summary, .py files contain source code written by developers, while .pyc files contain compiled bytecode generated by the Python interpreter for faster execution. Both types of files are important in the Python development and execution process. That's all for this video. If you found this video helpful, don't forget to subscribe, give it a thumbs up, and hit that notification bell for more content, so you don't miss any upcoming video. And, if you have any questions or topics you'd like us to cover in future videos, please let us know in the comments below. Until next time, keep exploring and keep coding. Thanks for watching, and happy coding.